supposed to enter.
But it's silent.
Oh, the ugly guy? Oh, you mean
Mr. Park, your other blue pants were super nice.
Yeah, but I don't like the way Kentucky Fried Chicken.
Yeah.
I love that. No.
Jason,
Okay, look, I changed the assignment sheet, so you guys need to know. The test is now next Wednesday. That's because Monday is extended and we are not going to do a 42-minute test in 70 minutes. This is the exact, pretty much the exact same test I've been giving AB for the last 20-something years now. So they only had 42 minutes before, so surely you can do it in like 55 minutes.
Like a little bit mentally challenged.
Oh, I'm sorry.
We're slightly
Too bad.
below.
We had the beast curve already and it's in the second quarter.
It actually did.
Anyway, last night's homework was the review for
Does
this.
anyone have a pencil?
So, now I don't know if you guys know this, but look on the website. Did you know that there's complete solutions for the review worksheet? Did you guys look at that?
Yes.
Yes or no? Look.
Yes.
Look here, solutions for chapter 5 review worksheet. Look.
I got a 5.
There's the complete solutions.
Yeah, but you
Hey,
The only problem is number 7.
Everything's due in like a week.
Number 7, Fong.
Do you have this?
At least you're not texting me.
I'm not.
Number 7, I changed the problem, so don't look at this number 7 solution. I changed the problem. Even if you do there's another review, there's like another review work. See, in the old days, I used to give them 2 practice tests before each test.
That's amazing.
Yeah, but now cannot, because we just don't have the number of days, so.
Well, that's why we're doing so fast.
That's why we're down.
That's why
Oh,
we
you're
need
not.
70 minutes
You
for
guys just gotta get used to what's going on.
What's the cheat sheet?
No, but just like second guess ourselves 5 times.
The cheat sheet is to prepare for the AP exam.
Oh, that's like
It has like everything you need to know for the AP exam.
That's
Oh, just
all.
look at that and just see.
Okay, so here we go. Review worksheet for chapter 5, right there, boom.
That's the solutions.
Oh, that's the solutions, boom.
Look.
Here, worksheet. Okay, so we're only going over one problem, the one that, are you sure that's the only problem? The other class, we had to do like several, you know.
Wait, no, actually, I think I have more.
That's what I thought.
Wait.
What, okay, here.
Tissue box.
Does everyone, look at number 8. The other
Yeah, I
class
have number
didn't
8.
even know what the second derivative test was.
Yes.
But Mrs. Goto actually wrote on the paper, she went over the second derivative test. And she got this.
I think.
Can we do number 8 too?
Okay, that's what I thought.
Is that just after?
Yeah, it's graded.
No, but,
wrong.
no.
That's the clock.
Okay, what about this number 3, the trigonometry one?
There's like
Okay, I'm gonna tell you right now, this is pretty much what the test looks like, you know. So like number 3, remember the last test with the trigonometry? That you guys didn't use double angle identity and
Okay, number 5 is
I'm
from
telling you
Eclipse.
guys gotta know the double angle identity. Of all the identities on the AP exam, double angle is the most prominent one. You gotta know double angle identity. Okay, you know what? I'm doing number 3. Too bad. Why, everybody got it? If I walk around the room right now, everybody did it. I would bet all the money in my wallet.
How much is it today?
How much you get today?
Look, I got a $100 bill today.
Always loaded.
Oh.
You wanna bet?
Oh no.
Big
No,
spend.
no, no.
I know you
You
don't.
have to have that money.
Does it count?
Okay. Oh, hey, what does this mean? This
Means
0
that
to
it's
2
always,
pi.
you don't need the absolute value.
no, it
No,
means
no,
that.
no.
Oh.
It's not above 2 pi or below 0.
You
Yeah, but what does that
have to include.
mean?
You have to
You got
include-
endpoints, there's endpoints.
Yeah.
Oh, so you have to check
Those
those.
points.
Yeah, so if you do not consider those endpoints, you're gonna lose half the point. So if you have 8 problems, I'll make it 8 points each. I'll give you 36 free points. Okay. Okay, now it says find all maximum and minimum points. Okay, here we go. First derivative, sine box is cosine box times the derivative of box. The derivative of sine is cosine. You need to make a number line for this, so you need to factor it. But I can factor out a 2. But what do I do with this, cosine 2x? You have to use double angle identity. I'm telling you, almost every single test from the last test is gonna have a double angle problem. You guys gotta be able to handle it.
Cosine squared.
Now, cosine 2x, there's 3 identities. Mr. Park, I don't know any.
Cosine squared x minus 1.
That's not one.
Minus sine squared x. It's minus
No.
Squared x.
Cosine squared
Okay.
x minus 1. Okay, look. 2 cosine squared x minus 1. 1 minus 2 sine squared x, or cosine squared x minus sine squared x. Do we need a speed quiz on trig identities again?
Yes.
I think we do. And then plus cosine x there.
Yes.
See how I put it? See how I put it in like descending order, so I'm ready to factor it now? Because some of you on the last test, remember you guys are drawing unit circles and trying to like guess and check. You gotta use double angle identity. And what a surprise, this thing just factors so nicely. 1 and 1, plus and minus. Okay, so somehow you gotta get to this stage over here. If you don't know the double angle identity, it's pretty much all over. Just take the -8. Mr. Park, you know what? You know what the other class had the gall to say? Mr. Park, I'm just gonna skip this problem. 92 is a Dartmouth score. They had the gall to say that.
It is a dark.
Well, that's assuming you get everything else correct. But then, maybe on the other hand, some of you would just spend like 10 minutes on this and get nowhere, yeah?
Yeah.
Yeah.
No, you.
That's why we need the second
Cost benefit, you know.
If you want to get a 5,
cost.
no,
Margin of benefit.
if you want to get a 5 on the AP exam, you gotta handle trigonometry and logarithms.
Yeah.
Yeah.
What percent you have to get to get a 5?
Oh, wait, do you
I don't want to talk about that yet.
No, math I think is hard because everyone's
Just to get like an A.
Yeah.
No, all you need is like a 75%,
wow.
and that's a 5. Can you get a C on the test?
Yeah.
Yeah.
We can
Barely.
see.
It's
We can
not,
definitely get
it's
some.
not as easy as you think it is.
I just got a
Barely.
C, so.
Okay, so here we go. Oh, making a number line. Now remember, on the test, I am also grading your number line. If it is not labeled like this, you lose a point.
Yeah, Andrew.
Alrighty. Okay, now, what would make this thing 0? When is cosine equal to a half? So it's like this. Pi over 3 and 5 pi, what? Well, no.
Oh, no.
No, not negative.
Okay, yeah, sorry.
Now what about this one? Cosine of what angle is -1? Pi. So these are the numbers you need on the number line. Now we test. What's a good number to plug in here?
0.
0. Okay, good. Cosine of 0 is 1. So 2 minus 1 is positive. 1 plus 1 is positive. Positive times positive is positive. And if this is positive, wouldn't this be positive? Because if you plug in 0 and 2 pi, you should get the same result, right? Right. Yeah, so can you see that this one's not going to alternate? Remember I told you when you have trig functions, you don't know what's going to happen. What's a good number to plug in here?
2 pi over 3.
How about pi over 2?
Yeah.
Why not pick something, a quadrantal angle if possible? Because cosine of pi over 2 is 0. 0 minus 1 is negative. 0 plus 1 is positive. Negative times positive is negative. And then what's a good number to plug in here?
3 pi over
3 pi over 2. Cosine of 3 pi over 2 is 0. So the same thing, right? 0 minus 1 is negative. 0 plus 1 is positive. Negative times positive is negative. Now, if I want to complete the maximum number of points you can get on the number line, what do I need to write underneath this? Y is increasing.
Wait, do we write y is increasing, or can we just write?
No, you gotta write.
No, you gotta write Y.
Okay.
You increasing me, because, okay, on the AP exam, you have to show them that you know the relationship between the first derivative and the original function. Yeah, that's what they want to see. Y is decreasing. Y is decreasing again. Now, some people, even though I'm telling you this now, every year, you know what students do? They just go, Y is decreasing across the whole thing here. -1. How come?
Because it's not the same.
No, because at pi, it is neither decreasing or increasing, because if you plug in pi, you get 0. A function is decreasing when its derivative is negative. 0 is not negative, so that's why you have to make 2 separate ones. You understand?
Yes.
Okay, y is increasing. There, now you have completed your number line. Now let's answer the question. Now remember, you have endpoints, so there's going to be an endpoint there and an endpoint there.
Oh.
Yeah? So, what is this endpoint here? Is that a max or a min?
Local min.
It's a min. Well, we don't know if it's
Oh,
local or
okay.
all we know is it's a min at 0.
At least.
Yeah. Okay, what about at pi over 3 here? It's a max. Now, again, we don't know whether it's local or absolute yet. What about at pi? Max, min, or neither?
Neither.
Neither, because if it goes downhill and downhill some more, that's not neither a max or a min, yeah? What about at 5 pi over 3?
Min.
Okay, min. And then what about at 2 pi, the endpoint?
Max.
Okay, max, good. But see, there's so many points left. Okay, now how do I figure out these y coordinates? You gotta plug it back into the original. This is where the other class had problems. Now, of course, they could plug in 0, because sine of 0 is 0. 0 plus 0 is 0. So 0, 0. Okay, but this is where they had problems. Pi over 3. Okay, let's plug in pi over 3. 2 times pi over 3 is 2 pi over 3. Sine is root 3 over 2. Plus 2 times sine of pi over 3. Root 3 over 2. So what is that? 3 root 3 over 2. That's right. Can you guys do that? Or just take the hit? Well, you need to put in some number. You have the reason why you have to put in a number, even though it's wrong, is you gotta compare the two maximums to see which one is bigger. That's why. So even if you don't know, make up something like 1. Just take the hit on it or something.
Take that out.
Okay, now 5 pi over 3. 2 times 5 pi over 3 is 10 pi over 3.
Oh no.
It's the part that's too big, so subtract 2 pi from it.
4 pi.
Look, if you have 10 pi over 3, that angle is too big for you, so didn't your teacher tell you subtract 2 pi
Yeah.
to get 4 pi over 3? Okay, 4 pi over 3 is there. What is the sign of that? Negative root 3 over 2 plus 2 times sine of 5 pi over 3. What is the sign of 5 pi over 3 over there? Negative root 3 over 2. So that's going to be negative 3 root 3 over 2.
Oh jeez.
So for some of you, that's probably the hardest part of the whole problem, yeah?
Yeah.
Yes.
No! You took already 2 years of trigonometry already. Okay, now look at your two minimums. These are, which one, what's smaller, 0 or this negative number?
Negative.
I think this negative number is smaller, so this is the absolute minimum, and this is a local minimum. Now look at your two maximum, what's bigger? This positive number or 0?
Positive.
I think a positive number is bigger than 0, so this is the absolute maximum, and this is the local maximum. Now you got 8 out of 8 points.
Which part? On the AP exam, do they give nice numbers?
Sometimes.
You mean like right here?
Yeah, like how it comes up. to
Yeah,
0.
yeah. Well, if it's on the no calculator part, if it's on the calculator part, right, then you don't, honestly, if it's a calculator problem, then once you take the derivative here, you just graph it on your calculator to make this number line, right? But if it's on the no calculator part, then you got double angle. This is the key to the, if you don't know your double angle, pretty much you're gonna get a -8. No, because, okay, -7, maybe, if all the rest of the work is correct. Because like I said, if you make a mistake, and then your problem becomes easier, it's very difficult to get partial credit. Okay, next problem. Somebody said number 7, so let's do number 7. Okay, now, that's because the solutions is wrong, that's because I changed the problem here. Now, remember we went over this last time? I told you this problem is on the test. It's on the test. In fact, all of those are on the test right there. So, that's why it's a practice test. 1, 2, 3, 4. 1, 2, 3, 4. Okay, let me draw this graph correctly. X-intercepts at -3 and 2. And then it goes up like this. And then at, where does it hit the maximum?
Oh, after -1.
Yeah, it looks like -1. So it goes up, makes a maximum at -1. Then it comes down and it bounces off like that. Okay, so here's f prime. I'm going to give you the graph of f prime. Actually, the one we did last time is harder than this one. You got to sketch the original function on the given axes over here. That's what you're going to do on the test. So what did we do yesterday? Make number lines for the first and the second derivative. So here we go. First derivative, number line. Second derivative, number line. Now, this is the graph of the first derivative. So you just make a number line for it. Where does it hit the x-axis? -3 and 2. Over here it's below, so minus. Over there it's above, and then it's above. What do I need to write underneath to get full credit? Can I write y is decreasing? No, you just lost the point, because it's f. F is decreasing. f is increasing some more. So that means we're going to have a minimum point at -3. Now, second derivative is the derivative of the first derivative. It's the slope of this graph. So what did I tell you to look for yesterday? Where is the slope 0 or doesn't exist? Well, there and there, right? The slope is 0. And where would that be? -1 and 2. So try to line it up because it's going to make the graphing easier if you do. Now, how do I fill in the signs? Well, we're graphing the slope. We're looking at the slope. So if the graph is going uphill like this, what can you say about the slopes?
Positive.
They're positive. And then if the graph is coming downhill like that, what can you say about the slopes? They're negative. Uphill, positive. You're making a number line for the slopes. What do I need to write underneath this? If the second derivative is positive, that means f is concave up. This one is f is concave down. F is concave up. So that means you're going to have points in inflection there, -1 and 2. Okay, so on the original graph, we're going to sketch the function. We'll just use blue chalk here. Now you can start anywhere you want. Where do you want to start? There. Okay, -4. So just look at your number line. From -4 to -3, what's happening? Look, right there. It's decreasing.
Concave up.
So we have to draw it going downhill, but concave up. So what? Something like that. In fact, look, starting from -3, it's just, so that from here, the graph is going to just keep on going uphill already. So basically, you just got to look at the concavity now. So from -3 to -1, it's going to be concave up and increasing. So how about something like this? Concave up and increasing. Okay, and then what about from -1 to 2? It's going to be increasing and concave down. So, and then finally, from two on, it's increasing and concave up. So, yeah. So as long as your graph looks something like that, you get full credit. Yes.
How do you know when it crosses the x-axis?
You don't know.
Oh.
Like you could have drawn it like this, and then it doesn't cross the x-axis at all. It just depends where you start. That's why, or how pronounced you make your bulges, right?
But then,
Because some people
Like this
some people like big bulges, so they go like this. Whoa! Ah! That looks kind of obscene, actually. But whatever. Now we're doing number 8.
Wait,
Yeah.
in general, so you have the points of inflection come from the second derivative.
Yeah. So when the graph changes concavity from up to down, see, so right there would be. See, like -1. Where's -1? Like right here.
Points of
See right there. See -1? See how the graph went from concave up and then now it's concave down? That's what a point of inflection is, where it changes concavity.
so it,
Okay, now the other class, they didn't even know what the second derivative test is.
oh, I don't know.
Do you guys know what it is?
Wait, let me look it
When
up.
you have this, there's a,
Mrs. Goto went over it.
Oh, yep, it's
No, not the mean value theorem.
at x equals 0, f prime a equals 0, f double prime a is greater than 0.
Oh,
And it's a minimum.
so she did go over it. You guys just forgot. Okay, so let's do it, because obviously we are befuddled, so.
Befuddled.
What does that even mean?
Befuddled means like you're like lost, you're like,
Discombobulated.
yeah, exactly.
Vocabulary in that?
Now, we're gonna find all extrema, maximum and minimums, but not the normal way. We're not gonna use the first derivative test, we're gonna use the second derivative test. Because they're gonna test you on this on the AP exam, I'm forcing you to use the second derivative test. So, what do you think I have to do? Before I even go on, do you even know what the second derivative test is, or do I have to restate it?
And we just said it.
I know she just said it, but some people maybe they didn't
Can you
take
say it
notes.
again?
Okay, that's what I thought.
Oh. There's a video.
Oh.
It's
So-
recording. See?
yeah, it is.
I got it.
Oh, it is.
Hi, Andy.
Okay, let me state the second derivative test.
What's the smell? Oh, there is none today, if there's no answer.
It does now.
Okay, if the first derivative is 0 at a point, if the first derivative is 0, and the second derivative at that same point is positive, then what do you have? Look, just use common sense. Look, draw a picture. If the slope is 0, and if the second derivative is positive, doesn't that mean concave up?
Yeah.
And the graph is concave up, what kind of point is that?
Minimum.
Then you have a local minimum.
Oh.
Did Mrs. Goto draw that picture? I'm pretty
Yeah.
sure she did.
What picture?
That picture. If the first derivative is 0, and the second derivative at that same point is negative, what do you think? Look, if the slope of the tangent line is 0, but the graph is concave down like that, isn't that a local maximum? Yeah. So this is called the second derivative test. Yeah.
What if it's not 0?
Then you can't use this test at all. So to even use this test at all, the first derivative has to be 0. Okay, so here we go. So first thing we gotta do is find the first derivative. Well, I see a product here, you gotta use the product. Derivative of the first, leave the second one alone. Leave the first one alone. And what's the derivative of e to the box?
To the bottom.
E to the box times the derivative of box, which is -1. What can I factor out?
E to the box.
E to the negative x, so 1 minus x. So the first thing you gotta figure out, when is the first derivative 0? What would make that thing 0?
1.
When x is 1. So when x is 1, the first derivative is 0. So that satisfies the first condition. We gotta figure out when the first derivative is 0. So now, normally what we would do at this point is we would make a number line, put 1, plug in a number bigger than 1, like 2. 1 minus 2 is negative and positive. Increasing, decreasing, that's a maximum, right? But that's called the first derivative test. We're going to use the second derivative test. You understand? Now, of course, in real life, you would just do the first derivative test, but this is to see if you understand the second derivative test. So now we need to compute the second derivative. Well, I see a product, use product rule again. Derivative of the first, e to the box times the derivative of box, leave the second one alone, plus leave the first one alone, and what's the derivative of the second? -1. What can I factor out? Now, do you want to factor out an e to the negative x or a negative e to the negative x?
Negative.
Yeah, I mean, it's up to you, it really doesn't matter here. What's going to be left? 1 minus x
Plus 1.
plus 1. So that comes out to 2 minus x. So now what you do is you take this number and you plug it into the second derivative. There were a couple problems on the homework where you had to do this. What happened then? I still gotta do my homework. Okay, what happens if I plug in 1? You get negative e to the -1 times 2 minus 1 is 1. Now, is this number positive or negative? That's all you gotta know. Is it positive or negative?
Negative.
It's negative, right? Because that's 1 over e, right?
Yeah.
Okay,
Well,
then-
this is the one you can't assume, or you gotta keep filling out the work, right?
Okay,
You can't just say it's positive and stop.
no,
Oh, that's a different one.
that's a different problem.
What is that?
That would be the linearization problem.
Yeah.
That's on number 4.
Yeah.
Anyway, this number is negative, so what does the second derivative say? When the first derivative is 0 and it's concave down, what kind of point is that? So at this point is a local maximum. This is called the second derivative test. Yeah.
Can there be more than one? Can you solve for more than one?
Yeah, so like, yeah, there could be, yeah, so what if there was like 1 minus x squared there? Then what makes this thing 0?
Plus one.
Plus or minus 1. And at each point, you would have to plug it into the second derivative to see if it comes out positive or negative. That's called the second derivative test. All right. Okay, now if you look at the assignment sheet, we are moving on to section 5.4 now. So so we have chapter 5. The title of chapter 5 is Applications of Derivatives. So last chapter, chapter 4, we learned how to compute derivatives. I'll put learn in quotation marks. And then now in this chapter, we're applying them to solve problems. So one of them is to find maxes and mins and points of inflection. Now we got the word problems now. So 5.1, 5.2, 5.3, 5.5, we just finished that. Now we're gonna do 5.4 and 5.6. These are all the word problems. We are going to spend 2 days on each one because for some reason students just don't like word problems, but you gotta get used to them. So today we start this. Now what the heck is section 5.4 about? It's about optimization. Now the other class, they kind of remembered these problems from last year. So what's going to happen is they're going to give you a word problem, and then you have to find like the maximum volume or the minimum cost of something. Remember doing problems like that last year?
Yeah.
Except last year you got to use your calculator, right? You graph it and then you calculate the maximum, right? This year we don't use our calculator, we use calculus to figure it out. Right? Because we just learned how to find maximums and minimums, right? You take the derivative and you make a number line. That's what we gotta do. So I'm just gonna do 2 examples and then we can go home. All right, the first, I'm gonna do an easy one and a medium one. So this one, we split it up into 2 nights. The first half is easy medium and then the second one will be medium hard. So let's suppose you're a farmer. You have a barn over here. And then you have these animals. What kind of animals do you have? Sheep and goats, let's say. You have these sheep and goats, but you want to keep them separated. Because if they like start mating with each other, there could be problems, right? So you go into the barn and you notice, hey, I have 120 feet of fencing. Okay? So how can I build a rectangular pen for these sheep and goats to keep them separated, but I can use the barn as one side? You know, I don't have to use fencing for that. So in other words, how can I build a rectangular enclosure with this 120 feet of fencing so that I can separate the sheep and the goats like this? Now, how many different ways can you do it if you have 120 feet of fencing? Like, I have no doubt some of you would just build it like this. Here's the barn. You would go, okay, 1 foot, 1 foot, 1 foot, and then 117 feet like that. 1, 1, 1. But then, that's unhealthy because the goats and the sheep, they got hardly anywhere to go. All they can do is this, they cannot even turn around. You know what I'm talking about? So you want your goats and sheep to be healthy, so how can I build this rectangular enclosure so that it encloses a maximum area? See, like this is minimum area. You know what I'm talking about? Plus if there's grass, they want to graze too, right? Okay, so luckily for you, I don't know if you guys even noticed this, but if you look at the website, because the book, it doesn't give you too many pictures, that's why. And you guys already have problems with word problems as it is. So if you look at on the left-hand column, look right here, diagrams for 5.4. So if you click on that, I give you the pictures. Okay? Now, maybe you should actually try it without pictures first, and then if you don't understand, then you click on this. You know what I'm talking about? Yes. But you don't need to worry because on my quizzes and tests, I'm going to give you the pictures like this too, so it's going to help you out. All right, so let's do the problem. AP exam, sometimes they don't give you pictures. Okay, so if I were, this is what I'm going to do. If I give you this problem on a quiz, which is possible, I'll have this picture right here. So so the first thing you got to ask yourself is, what are you trying to maximize or minimize in this problem? The area of this rectangle. So the first thing you do is, look at this picture. What is the area of this rectangle?
Oh no.
Oh no, the area.
X
X times Y, right? Length times width. We want to maximize this. But the problem is you got 2 variables. We only know how to take the derivative if there's only 1 variable there, right?
Yes.
Yeah, so we need to write another equation to get rid of one of these variables. Well, the only other information that we have is you have 120 feet of fencing. So what equation can I write from that? X plus X plus X plus Y is 120 feet, right? So 3x plus y equals 120. So what you're going to do is you're going to solve for one of these variables and plug it back into here. So most people would solve for y, yeah, since it's already there like that. 120 minus 3x. Take that and plug it in right there. So you got x times 120 minus 3x. There, that's your function. This is the hardest part of the problem. Because all the problems that we've had so far, the function was given to you, and then find the max and min. But now you have to actually write the function yourself. Okay, so now that you got it in this form, all you have to do now is take the derivative and make a number line. Well, what do you want to do? You want to use product rule, or should I multiply it out? I mean, it's up to you how you want to do it. What do you want to do? I would multiply it out, right? Make it in polynomial form like that. So I'll take the derivative. What? 120 minus 6x. Factor out 6. You get 20 minus x. Now we're ready for the number line. A prime. And again, I'm going to grade you on your number line now on the test. You gotta have that label there. What makes this thing 0? Duh, 20. Plug in a number bigger than 20. I was thinking 21. 20 minus 21 is negative, so negative and then positive. So what does that mean? A is increasing.
What's
A is the area.
Yeah.
Area is decreasing. So where do I have maximum area? Right there at 20. Now you know what the other class said? Mr. Park, isn't that just going to be 20? Because look, that's what makes it 0. Just because the derivative is 0, that doesn't mean you have a max or a min there. What if it was plus plus? What if the number line went plus plus? A is increasing, then you don't have a max or a min there. So just because the derivative is 0, that doesn't mean anything. You need this number line. So now from this number line, I can clearly see that x max is 20. You guys remember this last year, right?
Yeah.
Except see, once you wrote this, you graphed it on your calculator and then you G-solve max. But no calculator now. We use calculus. Okay, now, once you figured out x max is 20, you gotta answer the question. Now, I don't know how the book is gonna ask their question. So like, they could ask, what are the dimensions of this bar? I mean, this pen. Well, you would say, make x 20. What would I make y?
6.
How can I figure out where y is gonna be? Go back to this equation here. So what is 3 times 20?
60.
Subtract it from 120. Yeah, so there you go. So these are the dimensions of the pen. What if they were to ask you, what is the maximum area that the pen can enclose?
I'll be back in days.
Well, if this is 20 and that's 60, what? 1200, right? So once you figure this out right here, it's up to you to answer the question. Yeah, this will be an example of an easy one. Question.
And we're using the 20 because it's an absolute max? Or-
Well, this might not be an absolute, well, it is for this particular problem because if you graph this, it's a parabola, right? But you might have a cubic equation like this. Now, this is a maximum point, but it's not the absolute because it goes up forever. However, since we're doing like word problems, like x can only be positive, right? You can't have negative lengths, yeah? So even though it was a cubic function, on the domain of the problem, that would be the absolute max.
Okay. So there'll only be like one digit?
Yeah. Okay, let's do a medium problem now. And then we can go home. Oh, we're going home early. Okay, here is a sphere of radius
Wow.
6.
Yeah,
This is a sphere now. I'm just drawing like side view. Inside the sphere, I'm going to inscribe a right circular cylinder.
Oh.
Did you guys do this problem last year? I think your book had this picture in it. Okay. So how can I inscribe a cylinder in a sphere so that it has maximum volume? Because how many different ways can you put a cylinder in a sphere? Well, you could make it like really thin like this, like a straw, but the volume is not very big, right? Or you could make it like wide like this, like a poker chip, but that volume is not very big. So to have maximum volume, probably gonna look something like this, yeah? Yeah, so luckily for you, I'm probably gonna give you a picture. So probably my picture is gonna look like this. It has a big hint in it. Like that. Oh, and the radius is 6, so 6. Because how many of you would even think of drawing that right triangle like that? Yeah, so that's why I think, look number 22. See, I drew it like that. So look, I'm doing one with 6. Can you do one with 10? Well, we'll see. Okay, so what are we trying to maximize in this problem? The volume of the cylinder. Now, remember when we did the pre-calculus review in the beginning? You have to know all your formulas for volumes and surface areas of cylinders, cones, and spheres. Well, I'm assuming you're gonna know it, because if you don't, because I'm telling you right now, AP exam, once in a while they'll give you a formula, like if it's a bizarre shape, but like cones, spheres, and cylinders, you pretty much gotta know those formulas, you know. Okay, so here we go. If this is the picture, look, I got 2 out of the 3 sides of a right triangle. How do I figure out this third side right here? Okay, so can you guys just look at it and go square root of 36 minus x squared? Okay, what if you cannot? What if you cannot?
Box.
Very good. So you guys remember the box method. Call that box. Pythagorean theorem. Box squared plus x squared equals 6 squared. Box squared is equal to 36 minus x squared. So therefore the box is equal to the square root of 36 minus x squared. Now I don't care how you do it, you just gotta get it. So let's do it. What's the formula for the volume of a cylinder?
1/3.
Pi, no, that's sphere. Cylinder. Pi times the radius squared times the height. But we need to write that in terms of only one variable, and that variable is going to be x here. Okay, now look at this picture. What is the radius of this cylinder? Isn't this the radius? Okay, so pi times the radius squared times the height now. Look at the picture. What is this height right here? 2x, that's right. Now it's all one variable. That's what you want. You want to write it in terms of one variable so you can take the derivative. Let's simplify this. 2 pi x, and when you square a radical, no more radical. Okay, there you go. That's the hardest part of the problem. Now, how do you find the maximum of this function? Derivative and number line now. What do you want to do for derivative? You want to use product rule, multiply it out? Okay, I'll tell you what I would do, and it's up to you what you want to. You see this 2 pi? I'm going to leave it because it's a constant, and then I'm going to take this x and distribute it. Can you see why that's going to be good? You can do whatever you want. You want to use product rule, use product rule. Because when you make your number line, aren't you going to factor out stuff anyway? So why not factor that out right now? Okay, whatever you want to do. So derivative, 2 pi is a constant, throw it on the side. What's the derivative of that thing right there? 36 minus 3x squared, that's right. Can I factor out a 3? Yep, and you're going to get 12 minus x squared. Ooh, so 6 pi times 12 minus x squared. Now, can we just leave it like that, or do I have to change that to root 12 plus x and root 12 minus x? I think we're good enough, we can just leave it like that. I think we're ready for the number line. What goes on the number line? What makes this 0? Plus or minus root 12. Now, I don't care if you put root 12 or 2 root 3, it doesn't matter to me. The higher up in math you go, you don't need to simplify radicals. Radical 12, good enough. You don't have to simplify it to root 3. Okay, think of a number bigger than root 12. So I'll put root 12 there. I don't care which one.
4.
What is 4? Okay, 4. Plug in 4. 12 minus 16 is negative, and because this is positive, right? Plug in 0 here. 12 minus 0 is positive. And we really don't care what's there. How come I don't care?
Because
Yeah, because x represents a length. You cannot have negative length, right? So basically, that's all you need on your number line. V is increasing. V is decreasing. So now we have verified that the maximum volume will occur right there when x is 2 root 3 or root 12. Okay, but now you got to answer the question. Yeah.
is it also always, or like usually going to be like kept that way?
No, because, well, yeah, in the easy problems it is, but on the harder problems, on your number line, you might have like 2 things like this. You're going to have 2 things, and it's going to be minus plus, so increasing, decreasing, increasing. So this one will give you a maximum, but this one gives you a minimum. So that's why you're going to make the number line. Now I know some of you guys are gonna figure out some shortcut. Like the last class said, isn't that the answer already? Yeah, but on the AP exam, the answer only counts 1 point out of 5. So you gotta get the other points if you wanna get a 5 on the AP exam. Okay, answer the question. What kind of questions could they ask? What are the dimensions of this cylinder? In other words, what are the radius and height of this cylinder that will give you the maximum volume? Well, if x is 2 root 3, what would the radius, here's the radius, this is the radius right here, what would the radius be? We'll plug in 2 root 3 there. Root, maybe you guys should think root 12. What is root 12 squared? 12, 36 minus 12. Root 24, so 2 root 6. You can write root 24, that, I would accept that. And then what's the height?
2x.
The height is 2x, so if that's x, two of those is 4 root 3. Or they might ask you, what is the maximum volume?
That's why you
Well, you can just go pi times this squared times that, right? Or you could just plug it into this, because these are the functions for the volume, right? So what do you want to do? Plug it into this one? This one looks like the easiest to plug into. Let's do it then. 2 pi times 2 root 3 times 36 minus 2 root 3 squared. 36 minus 12. 24. So what does that come out to? 96 pi root 3. There you go. So you have to answer. I don't know what the book questions the book are going to ask you, but you got to answer it. But every problem is done the same way. You write the function, take the derivative, make a number line. Just like we've been doing. Okay, are you ready to go home?
Let's see.
Okay. We'll see you on Monday. Monday we're hoping to start the movie. We never even watched the movie yet.